Hello everyone and welcome to Ocean Cadence. Today we'll be undertaking the topic of steam traps and their utility in the steam lines. Now first of all, before going into the different types of steam traps, we have to deal with what actually is a steam trap. That is, what is the functionality of a steam trap. So as the name suggests, steam traps, that is a device that is meant to trap steam. Now trap where? Actually, it is meant to trap the steam in the circuit of circulation, that is the lines within which the steam is circulating. But why so? We all know that the purpose of steam trap is only to allow condensate to escape out from the discharge side of its line, so that whenever the steam is in its absolute condition, that is still in steam form, may it be saturated or superheated, the steam will not be allowed to pass through the discharge line. The idea behind this is to make sure that whenever the steam converts into water, it is appropriately drained and returned into the return circuit, and thereby causing negligible loss of live or utilizable steam from the circuit. But there is also one specific reason behind doing so. That reason is that when the steam is circulating in the line, the amount of heat that can be dissipated from the steam itself to warm the other fluid or the other substance that it is supposed to warm up is lesser when it is in a particular state than from what is compared when the steam is changing from the saturated steam state to saturated liquid state, that is the latent heat. To utilize this latent heat, we have to make sure that the steam remains in the circuit until the very point of time it is converted into saturated water, and thereby this saturated water, that is the condensate, is discharged from the line, that is the return line, and then collected back into the condensate collection circuit. That is why these steam traps are fitted in the line. Now, as we all know that the steam traps would obviously be in the return circuit to make sure that the steam is entirely utilized before the condensate is actually allowed to drain through the return line. So the steam traps make sure that the energy efficiency, that is the energy conversion efficiency of the steam, is completely utilized before the condensate is allowed to pass. So the proper functioning of a steam trap is extremely important to make sure that live steam in its pure form does not escape the circulation circuit and reach the condensate circuit, as it will create a lot of haphazard phenomena not only in the line but also in the afterward devices, and the circulation line temperature will also go higher, whereas the heat loss from the steam line into the adjacent chambers would not be sufficient enough, so the heating of large volumes such as the bunker tanks or freshwater tanks would not be done at optimum efficiency. Now that we're clear about the purpose of a steam trap, let us move on to the types of steam traps. So first we'll be undertaking the mechanical steam trap. As the name suggests, the mechanical steam trap is nothing but a mechanical device that utilizes the specific gravity difference of steam and water. Now what it does is, just like a lot of other devices where float chambers are used, the mechanical steam trap also uses a float chamber design. In this, when the chamber is completely filled with steam or partially filled with water but not up to a significant level, what happens is that by its individual weight and the action of the steam pressure from the top, the ball weight would act downwards, and thereby the pivot and the lever will also move downwards. This means that the disc is resting onto the seat, and thereby the passage for the passing of the condensate water is always blocked. Now, as the condensate level increases, you will witness that the ball float rises up due to the higher water pressure acting on the lower surface of the ball weight. At one point of time, the level of the condensate would be so much that the ball weight would be in upright position. This means that this disc has lifted completely from its seat, thereby allowing for the free passage of water, that is the condensate, from the discharge side, and this will occur until the point of time where the initial condition is restored. The advantage of this steam trap is that it has a large volume dealing capacity. That means once the float is lifted up, it will allow a high amount of discharge to occur. But as a virtue of the mechanical moving parts as well as the ball weight itself, the operational time of the mechanical steam trap is a little more higher as compared to the other designs. And also because of the moving parts itself, it requires a little more maintenance than the other designs. So now let us move to another improvement design, which is the thermostatic steam trap. Now, in mechanical steam trap, where we utilized the virtue of specific gravity, in thermostatic steam trap, we utilize the phenomenon of differential expansion coefficient in the presence of steam and condensate water. So let us see how. Now, as you can see in the initial part, when the entire chamber is filled with steam, the bellow which is inside is in its expanded form. That is because of its variable expansion coefficient. Under the high temperature of the steam itself, the bellow is in a expanded state. However, as the steam is condensing and the water fills up the chamber, the bellow would contract back to its contracted shape. What this does is that a critical part which is attached to the bellow is the pivot lever, which holds the wall disc to the seat, would be allowed to travel down, and by moving this disc off its seat, what it will allow is for the water to pass through the open passage available, and therefore the condensate to drain and flow out. Thereby again, when the condensate level is not enough and the steam is filling the majority part of the chamber, the bellows would expand again and retain the original shape, and thereby closing the trap condensate drain side or the return line. Now what this does is that it reduces the number of moving parts interlinked. That is, the entire procedure is dependent upon the expansion coefficient and the differential of the bellow and its material nature. So it gets rid of the moving part. However, one part that still remains is the movement of the disc itself. And as we know that because the expansion coefficient is variable, the lateral expansion of the bellow would again take a certain amount of time. Therefore, the time redundancy factor is still there in the thermostatic steam traps. Which now brings us to the thermodynamic steam traps. Thermodynamic steam traps are by far at present one of the most utilized designs and patented designs that are applicable not only in the marine but also in the industrial sector. So now let us understand how this steam trap works. As the name suggests, the thermodynamic steam trap utilizes the thermodynamic property of steam to control its flow and the regulation of the condensate. Now, first let us assume there is a situation where there is condensate in the line and the disc is sitting on the seat, that is the open passage which is available. So, this water that will gush in from the inlet would act in this small passage and allow the disc to move upward. So the disc has already started to float and the water is already allowed to escape. Now, even when the water travel upwards and on the rear side of the disc, the surface area of action of the water pressure on the top side and the bottom side is equal. So what happens is the disc will keep floating in its equilibrium condition and the condensate would be allowed to escape continuously until the very point of time that flash steam comes into the line. Below this is the strainer that is meant to make sure that no external particles will gather into the disc side, and also this makes sure that the disc movement is free of obstruction and also to allow a change in the curvature passage of the flow of the condensate, which is utilizable in the next part that I am going to explain you. Now let us understand that if there is a hot condensate, so initially when the condensate was flowing, that for instance when we are using a steam line, after a long period of time the condensate which will initially flow is cold, so the phenomenon that I just explained you will happen. Now after that, since steam has started circulating into the line a little bit, so hot condensate initially will come and there would be a time where the condensate condition would be of saturated water, that is the hot condensate. So what it will do is when the hot condensate faces a change of curvature and then move upwards, what happens is over here it creates a significant drop in pressure, that is a low pressure region. By doing so, what happens is that this low pressure region actually creates a suction or pulling force on the disc. thereby disturbing the equilibrium which was created due to the mutual existence of water on the top and the bottom. Also, when this flash steam and its pressure moves upwards, it acts on the surface of the disc, thereby the force acting from the top and the suction pull created at the bottom will draw the disc downwards, thereby closing the disc, and the steam trap operation will be concluded. Now this state will again remain until the point of time where the condensate has returned in the line and simultaneously repeating the entire cycle that I just explained. Also, it is important to understand that because of its high utility, the thermodynamic steam traps are very robust in nature. But sometimes you will notice that due to the corrosive nature of the steam, which is due to the lack of care that is being provided to the boiler water and the feed water, what happens is that a lot of corrosive material ingress occurs into the return line and thereby the steam trap. So even after opening the circulation of the steam, you will still feel that the return line is cold. That means your steam trap is stuck. Under such condition, it is imperative that after safe isolation and draining of the line, what you need to do is that you have to open the lock nut at the bottom side of the steam trap with the adequate spanner and draw this strainer out. By drawing this strainer out, it will allow you not only to clean the strainer but also mechanically drain the cold condensate that is deposited into the line, thereby also removing the rust content and allowing you to clean the filter subsequently. After cleaning, again you have to box back this strainer and it has to be made sure that the strainer exists into the line at all point of time to make sure that the steam trap is working properly. Otherwise, it will hinder with the operation of the top of the steam trap, that is the main action zone. I hope that a comprehensive explanation of all the types of steam traps has cleared your understanding of the subject matter. And if you still feel that there are any existing doubts or any improvements in the concerned topic, do let us know in the comment section and we'll be happy to address them or inculcate them into the video. Also, I request all my viewers that if the content is worthy of your time, do like the content as well as subscribe to our channel and share it with your colleagues and friends. Thank you so much.